Welcome to the Explainer. Today we're going to demystify something you probably see dozens of times a day, but maybe don't think twice about. That little lock icon right there in your browser's address bar.
So yeah, have you ever actually wondered what that thing is doing? Because it's so much more than just a little symbol. It's really the final move in this incredible cat and mouse game of digital security. Okay, let's dive right in. All right, first I want you to imagine the internet with zero security. None. It's just a completely open channel between you and, say, a website server. In a world like that, any communication, we're talking passwords, credit card numbers, you name it, is basically sent like a postcard. A hacker can just sit in the middle of the conversation and read everything in plain text. It's exactly like someone listening in on an old-school phone line. This is what we call a man-in-the-middle attack, and it is a massive, fundamental security problem. So, what's the obvious fix? Well, we encrypt our data, right? We turn it into a secret code, so that even if the hacker intercepts it, they can't actually understand what it says.
The first way to do this is called symmetric encryption. Now, think of it just like a safe that has one single key. You use that exact same key to lock the safe and to open it. It's pretty simple, right? You lock your message, you send it over, and the server on the other end uses its identical copy of the key to unlock it.
And right there, you've probably spotted the problem. It's a fatal flaw, really. How do you get the key to the server safely? Because if you just send it over that same open channel we were just talking about,
well, the hacker just snags a copy for themselves as it flies by. And now they have the key to unlock every single one of your secret messages. So yeah, this means symmetric encryption on its own just doesn't work for that initial critical key exchange. We absolutely need a better way.
And the solution is, honestly, it's a really clever approach called asymmetric encryption. And the best way to think about it is like a public mailbox.
So instead of having just one key, this method uses two completely different but mathematically linked keys. You've got a public key, which is kind of like the mail slot on that public mailbox. Anyone, and I mean anyone, can use it to drop a locked message in. But, and this is the important part, only the server holds the unique, secret, private key that can actually open the mailbox and read what's inside.
Now, this brilliantly solves our key exchange problem. Here's how it works. The server sends you its public key. You then create a brand new symmetric key just for this one conversation. You use the server's public key to lock it up tight, and then you send it back. Now, the hacker might see this locked box go by, but they can't open it. Remember, only the server's private key can do that. Now you both have a shared secret key for the rest of the chat. Pretty cool, huh?
So that's it. We've totally secured the channel. The hacker is locked out for good. We're done, right?
Well, not so fast. There is an even more devious problem lurking. What if the person you think you're talking to isn't the real server at all?
Right. What if this man in the middle isn't just listening in anymore? What if they're a master of disguise, an imposter who's pretending to be the website you want to visit?
So here's the con. The hacker just intercepts your request for the server's public key, and instead of passing it along, they send you their own key instead, and you have no idea you've been tricked. You think you're being safe, so you use this fake key to encrypt all your secret info, and you end up sending it straight to the imposter.
And that brings us to the final and maybe the most crucial problem we have to solve. How can you be 100% sure that the public key you just got is the real deal? We need some kind of trusted third party to vouch for the server's identity.
And this, my friends, is where the SSL certificate finally enters the picture. The best way to think of it is as a digital passport, or like an official government-issued ID card for a website.
These certificates are handed out by what are called certificate authorities, or CAs for short. You can think of them as the passport office for the entire internet. They are globally recognized, trusted organizations whose entire job is to verify that a website is who it says it is. And here's the key. Your browser, it already knows and trusts them right out of the box. So what's in this certificate? Well, it's a data file that bundles together all this crucial information: the website's actual domain name, its authentic public key, and, this is the most important part, a digital signature from the certificate authority that acts like a tamper-proof seal of approval.
Now, your browser does this incredible trust check automatically in just milliseconds. When it gets the certificate, it looks at the CA's signature and confirms it's legit. If a hacker tried to slip in a fake certificate, the signature wouldn't match, the whole check would fail, and your browser would throw up that big, scary, "This connection is not private" warning page you've probably seen before.
Okay, so let's put all the pieces together and walk through the complete secure process. It's known as the SSL handshake.
And that's it. In a fraction of a second, this whole dance happens. Your browser verifies the certificate, uses that now trusted public key to securely create a new secret key for the conversation, and establishes a completely private, encrypted channel. That whole process is what that tiny little lock icon represents. All of that complex security boiled down to one simple symbol.
This entire process really represents a frontier in digital trust. But the truth is, the methods we use to secure our data and our identities are constantly evolving just to stay one step ahead of new threats. And as more and more of our lives go digital, the fundamental question of how we prove who we are online, well, that's going to continue to be one of the most critical challenges we face. Thanks for watching.